Hello everybody, this is Accelerated Geometry, section 12.1, Trigonometric Ratios. We normally just shorten that down to trig. So here is a triangle. The hypotenuse is always across from the right angle. So we talked about this in class. So here's the right angle. That is like an arrowhead pointing to this side, which is the hypotenuse. So that side never changes its name. It's always the hypotenuse. Okay, now a guy comes on. You see the guy? He went and he stood at angle B. Okay, if you are at angle B, side AC is opposite from you. Okay, so this is going to be called, from where this guy is here, opposite from where he is going to be this side here. So if I say angle B is made by this side and this side coming together at B, see how the opposite side is not one of the sides making up angle B. Okay, then it says side AB is adjacent to you. You actually have two sides that are adjacent to you, don't you? You got this guy next to you, because adjacent means next, and you have this guy next to you, adjacent to you. But this one already has a name, hypotenuse. So that's why AB is adjacent. Okay, same triangle, but look how the names are different. This one is still the hypotenuse. That does not change. But now look what's happening. The guy is going and he's going to stand up here at angle C. Okay. If you are at angle C, AB is opposite from you. Okay, here are the two sides that make up angle C. The side that I did not put coloring on is opposite, the opposite side, totally opposite from where the guy is standing. Side AC is adjacent. Again, from where you are, right here I should say, that's adjacent to you, and this side is adjacent to you, next to you. But this one already has a name of hypotenuse, and so therefore, this is the one that is called the adjacent side. Okay, two triangles. Notice it's exactly what I had on the previous screen. And here the guy is standing at angle B, and here the guy is standing at angle C. Okay, so it says the sine, S-I-N-E, is equal to the abbreviation S-I-N, but we never call it sin, we always still call it sine, which is the opposite side over the hypotenuse. So if the guy is standing here at angle B, the sine of angle B would be opposite over hypotenuse. So whatever the value is of this opposite side, let's say it's 3, let's call this 3, 4, and 5. The sine of angle B would be the opposite over the hypotenuse. It would be 3 over 5. Cosine is abbreviated COS, but we never call it cos, we call it cosine. It is the adjacent side over the hypotenuse. So if I were here, the adjacent side to me is 4, and the hypotenuse would be the 5. So the cosine of angle B would be 4 over 5. The tangent is abbreviated TAN. It's the opposite over the adjacent. So the opposite side over the adjacent side, the tangent of angle B would be 3 over 4. Now, if I'm over here at angle C, the sine of angle C would be the opposite side. Let's call these 3, 4, and 5 again. Okay, the opposite side would be 4, and the hypotenuse would be 5. So the sine of angle C is 4 over 5. The cosine of angle C is adjacent over hypotenuse. That would be 3 over 5. And the tangent of angle C would be opposite over adjacent. So that would be 4 over 3. Okay, there's a way that people remember the sine, cosine, and tangent. SOHCAHTOA. See how I did these in red? Here's the sine, opposite over hypotenuse. That's where the SOH comes from. Here is the cosine. It is adjacent over hypotenuse. So that's where the CAH comes from. And here's the tangent. And here's the opposite over adjacent. So that's where TOA comes from. SOHCAHTOA. I could tell a story about, there's different stories here about people soaking their toes or whatever, but I'm not going to get into that. So SOHCAHTOA. So that's how people remember it. Like my pre-calc kids, when I start a trig test, I see at the top of many of their papers, they just write down SOHCAHTOA, just to remind them all about these trig ratios. Okay, so now if I have this triangle and I want to know the sine of 30 degrees, okay, here is the 30-degree angle, which means this must be the 60-degree angle. So the sine would be the opposite over the hypotenuse. So the opposite of 2, hypotenuse of 4. So 2 over 4, which reduces to 1/2. The cosine of 30 degrees is adjacent over hypotenuse. So it would be 2 square root of 3 over 4, and then I could cancel. 2 goes in there once, 2 goes in there twice, so I get 1 square root of 3 over 2. And the tangent of 30 degrees, if I'm sitting in this 30-degree angle here, it would be the opposite over the adjacent. So it would be 2 over 2 square root of 3. These cancel, so I get 1 over the square root of 3, but then remember you can't leave the square root of 3 in the denominator, so you get square root of 3 over 3. Same triangle, but now you're going to be at the 60-degree angle. So the sine of 60 degrees is opposite over hypotenuse. Opposite over hypotenuse. 2 square root of 3 over 4. 2 goes in there once, 2 goes in there twice, so there's my answer, square root of 3 over 2. The cosine is the adjacent over the hypotenuse, that's 2 over 4, which reduces to 1/2. And the tangent of 60 degrees is the opposite over the adjacent. So it'd be 2 square root of 3 over 2, and then those cancel to be the square root of 3. You can also do this stuff on your calculator, but one thing you have to do first, and if you do this once, it'll stay like this until you change it. Go to your mode key, and when you click your mode key, which is that red key there, this shows up, and over here, you get to choose radian or degree. So move your cursor over to degree and highlight that. And then you are able to use the sine, cosine, and tangent keys, which are on your calculator down here, 2 rows underneath the arrow keys. So to use my calculator, I say again, go to your mode key, be sure degree is selected, not radian. Okay, and again I say once you do that, then that's done. Okay, so the sine of 30 degrees, I punch in sine 30, and I get an answer of 0.5. I punch the cosine key, put in 30, and press enter, and it rounds to 0.8660. Tangent, press 30, you get 0.5774. To find an angle that has a given sine value, cosine value, or tangent, so you want to find the angle. Here you want to find the angle, you use the second key, and then you use your trig key. So I'm just going to go backwards from here. So I know from here that the sine of 30 degrees is 0.5. If they don't give me this 30 and they have me find it, they'll say the sine of x, not giving me the 30, is equal to 0.5. So I push my second key, then my sine key, and then I put in 0.5 and enter, and it'll give me back that 30 degrees. Again, this one here, if they don't give me the 30 and I have to find it, then I press in the 0.8. Okay, my pen is just dying here, so I'm just going to do something quick here. Okay, so I want to find what angle has this cosine, so I push in the second key, then the cosine key, then the 0.8660, press enter, and it'll give me back the 30 degrees, the same thing as this. If I want to go backwards and they don't give me 30, they only give me the value of the tangent, then I say second tangent, put in that value, press enter, and that'll give me back my 30 degrees. You might ask, why are these in 4 decimal places? Because a long time ago, before we had calculators, we used a booklet of tables, and in those tables, they always rounded trig stuff to 4 decimal places. So in honor of that, you'll see a lot of math people round trig things to 4 decimal places. Okay, now we're going to use this. At a distance of 36 meters from a tree, so here's the 36 meters, here's the tree standing, so this is 36 meters from the tree. The angle from the ground to the top of the tree, right there, is 31 degrees. Find the height of the tree. So now, if I'm standing in this 31-degree angle, what do I know? This side is the hypotenuse. They don't ask me what the hypotenuse is. They don't tell me any value for the hypotenuse, so I'm just going to ignore that. Adjacent, they give me the adjacent side, and they want me to find this opposite side from where I'm standing. So if I look at SOHCAHTOA, opposites and adjacents are given to me. So I find the one that has opposites and adjacents in it. This one has opposites and adjacents. This one only has opposite. This one only has adjacent. This one has them both. So that tells me I'm going to use the tangent. So the tangent of 31 degrees is the opposite over the adjacent. The opposite is the height of that tree. I don't know that. The adjacent side is 36. Now if I put a 1 underneath there, I can cross multiply. H equals 36 times the tangent of 31, and I can put that right into my calculator, and it gives me 21.63. Find the length of the hypotenuse of a right triangle if an acute angle measures 20 degrees, and the leg opposite the angle measures 410 degrees, and they want me to find the hypotenuse. Okay, so in this triangle, if I'm standing here in this angle, this would be the hypotenuse. This would be the opposite side. They give me the opposite. They want me to find the hypotenuse. They don't tell me anything about the adjacent. They don't ask me to find the adjacent. So when I look at SOHCAHTOA, I say, what do I have? What do they want me to find? They want me to find the hypotenuse. That's an H, and they're going to give me the opposite. So an O and an H. This one has O and H. This one doesn't. This only has the H. This one only has the O. So that's how I know I'm going to use the sign. So the sine of 20 degrees is the opposite side of 410 over the hypotenuse of x. If I put a 1 underneath there and cross multiply, I get x times the sine of 20 is equal to 410. Divide by the sine of 20 to get the x by itself. And then put that in my calculator. I actually, right here I put it in. I also could just go 410 divided by the sine of 20. That would probably be even easier. And when you do that, you'll get that answer. Okay, I have like 3 minutes left. A right triangle has legs of length 8, and here legs 8 and 15. Find the measure of the angle opposite from the 8-inch angle. So I want to know from the 8-inch leg. So I want to find that angle. Okay, so what do I know? If this is my angle, this is the opposite side, this is the adjacent side. They don't tell me anything about the hypotenuse, and they don't want the hypotenuse. So SOHCAHTOA, opposites and adjacents are tangents. So I say the tangent of that angle is 8 over 15. Now, this symbol is kind of the opposite of tangent. It wipes it out. So if I put it in the front, I have to put it in front of the other side also, and then these cancel each other out. So that means I'm just left with angle A, but I still have this. So to get this second tangent, 8 divided by 15, and I get 28. So hopefully that has helped you do the first section of the trig. There's only one more section left with some word problems in it.